course. Okay, other things that are weird. Types are completely dynamic, and I don't have to tell you this because you know about this because you've done JavaScript, right? But anyway, so imagine that we define a function called improved code, which takes in a value q and multiplies it by 2 and returns the answer. So if we ask, if we define code quality to be 4, and then we pass our code quality to the improved code function, we get back the answer 8. Okay, that's fine. Now imagine that we define code quality to be poor. Well, we can still pass it to that function. No one's going to object to us until we try and run it. And when we try and run it, it fails. So you're used to that. Dynamic typing is not weird anymore, right? Okay, other things. Functions can be treated exactly like data. This is what I said earlier. So imagine we have a function called double, takes in an argument called value, and it returns 2 times the value. And now let's make another function called apply twice. It takes in 2 arguments. One is called fun, and one is called value, and it assumes that fun, when you pass it, is going to be a function itself. And what it does is it calls that function on value, and then it calls that function on value again. Okay, it applies it twice. So if we pass in double and an argument of 2, we're going to apply the double function twice and return the value. So the result is of applying it once is 4, and then applying it again is 8. That's weird, huh? Okay, other things. So how do we know what's data and what's code? Well, actually they can swap around. So imagine we've got a function called swap23. Don't worry about the details of it, but look at that example in the middle of the page there. If I pass in 1, 2, 3 to that function, it returns 1, 3, 2. It swaps the second and third things in a list. So if I pass ABC to it, it returns ACB. Make sense? So now imagine now I've got a function. I'm defining a symbol called 4/2, which is a list. So this is not going to divide anything. That slash symbol there means divide. It's not going to divide anything. It's just a list of symbols. The slash symbol, the 4 symbol, and the 2 symbol. Don't worry about the quote. We will get to that, although it will take us quite a while. So what is 4/2? It is /4/2. Okay, makes sense. Now we have this function called eval, which means treat this as code. So if you treat that as code, we're going to divide 4 by 2, and we get the answer 2. Now let's make a new thing, a new symbol called switched, which is the result of running the swap23 procedure and passing the argument 4/2. Are you seeing where I'm going? So if I evaluate switched, what is the answer going to be? Well, let me give you some hints. 4/2 is going to have swap23 applied to it, so it's going to become /24. Then if we run that code, what do we get? Well, we get a half. Divide 2 by 4, you get half. And just to demonstrate what's going on there, if we look at switched, switched is /24, just as I said. Make sense? Weird, huh? Okay, so we've talked about how it's weird, but also it is deeply cool. And over time, hopefully, in these videos, you'll come fully to appreciate its coolness. But let's start with some hints, some little tidbits that you might consider cool. So we can do generic programming that doesn't care about type. That you can write your code once, no matter what type the arguments are, without any of that syntax you have in C++ or Java. You know, it's just you just do it. You just write the code. Generating code within the language without using some other language to generate it is incredibly easy. This clever thing called metaprogramming, which is writing code that builds code or code that is about code, well, in Scheme that's just programming. It's no different. There's these things called macros, which are kind of metaprogramming. Think of a C macro, but part of the language and easy to use and difficult to make mistakes. Well, in Scheme, macros are almost just the same as writing more code. And one of the things that you are going to learn to love is that there are a lot of brackets in Scheme. So let's have a quick look. If we pass a list 54321 to the sort function, and we pass in the less than operator as the way that you want to sort it, the operator you want to use to compare items, we get back 1, 2, 3, 4, 5. Now if we pass the list ABC, A and AB, and we pass in the string less than function, which is what that weird thing on the end there is, we get back A, AB, ABC, which is the lexical sort of these things. What's important to note here is that the sort function that's running there is the same code. So generics are easy. Okay, generating code is easy. Imagine that you define a function called d0, which takes in an argument called name, and what it returns is a list of the symbol define and the result of calling string to symbol on the name argument. A string to symbol is a built-in function which produces a symbol out of a string, and we're passing 0. What that means is if you call d0 with an argument of a, you get back a list of the word define, a, and 0, which looks like code, but at the moment it isn't code, it's just data. So now we can define another function called d0 list, and it takes in an argument called names, and what it does is it runs the map procedure, which calls a function on everything in a list, and the function that we wanted to call is the d0 function, and the argument, the list that it's going to run over, is this thing called names, which we passed in. So if we now define a symbol called myCode and define it to be the result of calling d0 list with a list of a, b, and c, then you can see at the bottom there that myCode becomes a list of lists, and each of those lists says define a0. This is all still data, this is not code. So, put me back where I live. Okay, so what is myCode? It's that list that we just saw at the bottom of the page. So let's evaluate everything in myCode using the for each function, which just does what you tell it to do. So that did nothing. Now we're going to ask what is a. Well, we've evaluated everything in the list above. We've run it as if it was code. So now a is defined to be 0, and b is defined to be 0, and c is defined to be 0. You didn't write define a 0, b 0, c 0. You just passed in a list of a, b, and c to a function. And just to check that I'm not cheating you, let's check what d is. Well, d is not defined. We've only defined a, b, and c because that's what we passed in. Okay, other metaprogramming we can do. Imagine we've got a function called double, a function called square. Imagine we've got a function called apply twice. Then we can define another function called quadruple, which applies double twice. And we've got another function called to the power of 4, which uses apply twice on square. And those functions work in the way they want, and we're using code to build new code in a way that is much more meta than you can do in a language like C. So, what I haven't even talked about yet, because they're too difficult, but are just the coolest things, are you can write your own language using macros. You can make things look entirely unlike Scheme, apart from the brackets, and you will acknowledge the power of the brackets. So, on your screen is how to install on Ubuntu the MZ Scheme interpreter. Do it. Thank you very much.